So today we are going to learn about merge sort. Now, merge sort is one of the most popular sorting technique. Essentially, it is a technique in which we divide our array into subparts till our array consists of only single elements. Now, we compare the elements with each other and we sort the array accordingly. For our simplicity, we will take an example and we will try to understand. So we have an array over here which contains 53, 13, 48 and 10. So it's in unsorted order, and first step is to find the mid element. So we will do length by 2 to find the mid element. Once we found the mid element, we will divide our array into two partitions. So the first one up to the mid will be the left array. Second one from the mid to the end position will be our right array. Now these two array will be treated as a new individual array, and we will run the mid function again and break these arrays into more fundamental pieces until and unless the array consists only one element. Now we will call the merge function. Essentially, the merge function will take the individual elements, and the first step is it will group it into left array and right array, and it will try to check which one is greater. So in the first condition, 13 is obviously not greater than 53. It is not in a sorted order. 13 is lesser than 53, so it is obviously not true, and so we will put the 13 in front and then 53. Same goes for the second condition. 10 is obviously not greater than 43, so it will return false, and then we will put the 10 in front of 43. These arrays of two elements will be considered as left array and right array again. So the first element of the left array is small. If yes, we will check the first element of both left and right array, and the smallest one will be added to a final array. So the first condition will be, is 10 greater than 13? So obviously it's not, so 10 is the smallest one, and so we will add the 10 to our final array. Since we added the element from the right array, we will increment the right pointer, so the right pointer will point to the next element of the right array without changing the left pointer. Now we will check if 13 is lesser than 43, which is true. So next element that should be added in our answer array should be 13. After this step, we will increment the left pointer. Now the left pointer is pointing at 53. Is 53 lesser than 43? Obviously not. So the next element that should be added to our answer array. Now we can notice that the right array, the R is pointing at the index which is bound, which is outside the right array, right? Which means that in short, we have exhausted all the elements of the right array. Once elements of the left or the right array is exhausted, that is, there is no more element left in the array, then we will break out and we will simply add the element in the order of the presence in the other array. So we will add all the elements of the left, starting from the left pointer till the array is completed. So only one element is present in our case, so we will add the 53 to our final answer, and that is our final array. So we got our sorted array as 10, 13, 43, 53. Now we will start coding right away. Okay, so in the code editor we can see that we have created an array and we have created a function called merge sort. So essentially merge sort is taking our array and it will give us the sorted array back, which will be printed. So we will declare merge sort as a function, and it should take an array as an input. Now first we will need the length of the array. So we will declare a variable length which will store the length of the array. If the length is equal to 1, that is the base condition, which means only one element is left in our array. In that case we want to return. Now we will declare mid. So this will be the middle of the array, and we will store the left part and right part in a separate array. So we'll declare a left array as well as a right array. Now we will need another index j to manipulate our right array, and we will run a for loop to copy the data from our array to our two freshly created left array and right array respectively. So if the I is less than mid, which means if it is less than mid, then we will add the I to our left array. If it is greater than mid, in that case the element should go to our right array. Create that and after that we will recursively call the merge sort for the left array as well as the right array. This will keep on dividing the array. Now once the division is done, call the merge function. Essentially it will try to sort and join the left and right array. So now we will have to declare the merge. So we will write private static void merge. It will take the left array and right array. So we will declare a variable called left size. This will be the actual expected size of the left array, and we will declare a right size variable. Similarly, this will be the actual expected size of the right array. And now we will declare indices I, L and R. So I will be used to get the elements of our original array, and L will be used for the left array and R will be used for the right array respectively. So we will create a while loop, and we will say while L is lesser than left side and R is lesser than right side. So as long as the indexes have not reached the actual length either of the array, we will keep on running the while, and we will keep on testing if the element present in the left array is lesser than the element present in the right array, and if it is, then we will add the element to our final array. We have to add the element of the left array, therefore we will have to increment the left. If it is not the case, the element present at the position R of the right array is greater, so in that case we will add the element to our answer array, and then we will increment the I and we will increment the R. Now we will create a while loop, and we will say, now essentially if any of the array runs out of element, we will break out of the while loop. Now we will create other while loops to add the remaining element from the either of the left out arrays. So first we will go for the left, and we will create a while loop, and we will say if L have not reached the left size or the expected size, we want to add all of the element from the left array as it is, and obviously it will be in the sorted order. Or else if the point index R have not reached the actual size of the right array, then we want to add elements from our right array to the answer array. So this is the code. We will try to test it. So we will put elements inside a array. We will go to the main function and try to put elements inside our array. So we will put elements of our test case, which was 53, 13, 43 and 10. Now when we try to run it, we are getting the expected output from our code. So it is saying that the sorted order of the array is 10, 13, 43, 53, and which is what we were exactly expecting.